virtual person.
Yeah.
So I think I'm just going to give you the, yeah, whatever it is, and just go at your own pace.
Yeah.
You got 3.
And can we move my other talk to the end, so I don't want to
Sure.
take more time if we are.
Sure.
time.
Yeah.
Thanks.
I'm actually going to give you the clicker, so you'll be able to control everything from this. All right, let's see. Do we have everyone who is presenting today? Folks online, let's see. It looks like Kyle. I think you're the only online presenter. Kyle, are you out there, and do you want to speak up and see how your sound is?
Yeah, how does it sound?
Sounds good.
Okay.
All right, cool. All right, I think we can get started. We have Sandy will be our note taker, and let's kick things off. So, welcome everyone. You are in MBONED, and there we go. Okay, here's the note well. Please make sure you are aware of the policies in effect on various topics, including and especially contribution, as in with all of our other working groups. And note really well that our policies, I guess everybody's familiar with these policies, but please be professional and be nice. Meeting tips. So everyone, please, those of you in the room, please be sure to connect to the data tracker for the room. We're going to use this to monitor the queue. So if you would like to speak, please enter the queue that way. This allows us to, among other things, manage the queue in fairness to the people who are online who may want to enter it. And yes, we only have one online presenter, I believe. And Kyle sounds like you know what you're doing and it's working well. Okay, here is our agenda. We have a full action-packed agenda today. Are there any bashes to the agenda? Okay, moving right along. All right, updates since the last meeting. First, we have a new area director. We thank Warren for his many years of service, and we welcome Med. Thank you for joining us. We were able to recharter recently, last month, successfully. Thank you for everybody for your support. Thank you, especially Med, for helping drive that. We also updated the milestones, which we may need to update very soon. There are a couple items were maybe a little bit more aggressive than we meant, but those are there. And we did some document cleanup. So there were a lot of expired drafts going all the way back to 1996. So we cleaned those up, moved them from expired to dead. We're about 2/3 of the way through that. I made the mistake of perusing these drafts before marking them as dead, and the process took a little longer. But I got to finish. We got about 12 more to go. But there's some interesting drafts, interesting documents in there. I encourage folks, if you want to see the history going back almost 29 years, there were some very interesting drafts and proposals along the way. In terms of active working group documents, the Yang models draft. Sandy, do you want to speak to that? You got a Yang doctor's review, and you did update the draft as a result of that. And what are you waiting on? Are you waiting for a review of your review? A review of your updated version?
Sunny Zhang, yes, about the Yang model and the redundant ingress file overdraft. We also addressed all the comments we received. So I think it can be moved on. Yeah.
Okay. I think, yeah, I actually mixed up the redundant ingress failover.
Yeah.
You received ops review from Tony. Has he responded to the update?
Yes.
He did.
Almost the whole draft has been rewritten because he thinks that the language is not good. So we make a large change for it. But the main idea is remain unchanged. Yeah, the idea is remain unchanged, but only the language are recognized. Yeah.
Okay, and I believe so. There was a routing director review requested. I don't remember seeing that. Did that review come in yet?
Tony Lee is responsible for RTG DIR review. Yeah.
Okay, I thought he did the ops directorate review.
OPS seems like there is. I address all the comments I received.
Okay.
Yes.
Okay, cool. All right, so maybe we'll go to working group last call on that one as well.
Okay, thank you.
And when we do go to working group last call, please do comment. We can't advance a document if it doesn't have working group participants, non-co-author participation in support of advancement of that document. There's also the AMT Yang document. I believe we're awaiting Yang review on that one. Sandy, are you a co-author on that one? The AMT.
The MT Young, we have requested the Young Note review, so we haven't received the comments.
Okay.
So I will waiting that.
I think we have a couple weeks left. We were in the deadline on that one.
Okay, thank you.
So, okay, and one great development since the last IETF was the resurrection of the multicast to the browser triumvirate of drafts, AMBI, DORMS, and CBAC. We have Max will be talking about all three. And so we thank Max and Kyle for picking those up. On the CBAC draft, we did get reviews from Ops Directorate and TSV. Those reviews are in, and Max, when you get up, if you could talk about, it was suggested to have the CC Congestion Control Working Group review that, so please do mention where that is. And the since last we met, which was, we didn't have a meeting in 122, but we did in 121, the non-source routed draft was adopted back in March. So I don't know, Is Jeffrey here? No. Okay. All right. Any other drafts? I think that's everything. Anybody else have anything to add to that? Okay. Sandy, if you want to come on up. Need to make it go. How do we make this go away? Um, Upper left. That button. Okay.
Yeah, and then you have to do it all over again.
Okay. All right.
Yeah, you got it.
There we go.
And you have to redo this, yes.
And we thank you, Mike. Takes a village. Okay, Sandy, here you go.
Thank you. Okay, good morning. This time I'd like to share our some study and research on the multicast use case in LLM MOE architecture. Yes, I'm Sandy Zhang from ZTE. So let me introduce the LLM MOE at first. The LLM means the large language model that is used widely today. And the MOE is the abbreviation of mixture of experts. And the MOE is a popular architecture in LLM. So when using MOE architecture, multiple experts can be activated during the computation. And only part of the parameters are used for each expert. We know that the LLM has become larger and larger. If we just use some limited GPU to do the computation, it will require the very high power. So if we use multiple experts to do the work, only part of parameters can be used in each expert. So the burden can be shared. So while using MOE can bring more cost-effective training and inference method. It enables the deployment of large models at almost the same cost. So we can use the more GPU to do the same thing, but need not with a single GPU with high performance. Yeah. So more and more LLMs adopt MOE architecture, such as DeepSeek V3, Llama 4, Mixtrail, and the Queen 3 eccentric. When the gating function is important function in the MOE architecture. So when using the gating function, the experts are selected. So the token will be sent to multiple selected tokens. To be noticed that this is the same token. Yeah. So this is a typical multicast use case here. So let's see the mainstream LLMs deployments. We know that Google, XII, or Mixtrail, and also DeepSeek V3, and so on, they all used MOE architectures now. So we know that the Mixtrail is the first business MOE LLM, and it is published in last year. And in this year, we know that more and more LLM has published the MOE version. So, and in them, we can analyze some of them. In Mixtrail, we know that it will has experts in total, and the 2 experts are activated at a time. One is routing expert, and the other is shared expert. And in Llama 4, for different version, it has different number of experts. In Scout version, it has 16 experts. But in Maverick, it has 128 experts, and 2 experts are activated at a time. And also, one is shared expert, and the other one is rooted expert. But in DeepSeek V3, we know that it has the largest number of experts for now, just for now. So it has 156 experts, and 9 of which are activated at a time. So one is shared expert, and the other 9, the other 8, sorry, the other 8 is rooted experts. So in that, when the MOE architecture is a trending. So this is from the DeepSeek V3 paper. We know that this is a gating function in the expert selected process. When using the gating function, tokens are sent to multiple selected experts. So the same token will send to 9 experts at a time. But we know that the expert is not always remain the same, because the experts need to be balanced. So it's difficult to always use the same set of experts. So maybe each token will be sent to a different set of experts for computation. So because we have so large number of experts, the experts are distributed. The experts is difficult for limited experts in a single node. So the experts will be distributed across different GPUs and nodes. So we may use the traffic across leaf switch, even if spine switch for computation. Yeah. So when using the MOE architecture, the communication of EP, that means expert parallelism, is used to replace some tensor parallelism. We know that the TP is always become calculated in one node. But when we use EP, the EP can be across nodes. So we know that there is some traffic must be sent across the leaf switch or even spine switch. So this is a typical multicast use case in RM and just one of many. So the motivation of this draft is we'd like to discuss if we can use network multicast technology to assist LLM multicast implementation. So if we using multicast technology here, we can reduce the pressure on the source GPU, because the source GPU will manage all the queue to the experts. So it will reduce the burden of the source GPU. And we'd like to reduce the possibility of congestion caused by bandwidth between nodes, because we know that the bandwidth inside the node is very large than the bandwidth between the nodes. So when we need to send the flow across the nodes, we must face the bandwidth restriction. So, and also we'd like to find the possibility of using multicast method for use cases inside and outside nodes, because when we can use the multicast for across nodes communication, maybe we can still use it in the node itself, such as scale up and scale out networks. But we know that this is a not easy thing. We may face many gaps here. So we know that currently the sending methods within the card may be memory reading, just the memory reading. And between the cards, we may use a link. And between nodes, we also use RDMA, and they all are inconsistent. And if we want to achieve this, we need a coordination between large model coding and the communication library, or even of a network card and network layer. So it's some difficulty here, yeah. And we'd like to find the suitable location for encapsulation, the, the multicast packet encapsulation. So, and also we may need some management of experts as special, especially in MOE scenario. Yeah. So let me analyze some existing multicast technologies here. And we know that PIM is a traditional multicast routing protocols and it's stateful. And so each flow state need to be maintained in the router. And it requires periodic signaling to build a distribution tree to forward flows. And it may be slow convergence if the tree topology changes. And the encapsulation of PIM is based on IP. And we know we have a new multicast technology, it's beer. And in beer, it's stateless because we need not to maintain the per group or per stream state in the router or switch. And we needn't to build a distribution tree. And forwarding is done just based on the topology. And we can achieve faster convergence to network changes because we needn't to rebuild the tree. And the beer header encapsulation is flexible. We can use Ethernet, MPLS, and MPv6. And we can also that the beer standards is very mature because maybe beer will be an ideal choice for implementing multicast in LLM, especially for MOE scenarios. And we know that we have published many RFCs, such as beer architecture and the underlay extensions, encapsulations, and also we have BRTE. So we may discuss the possibility of deploying beer for scale up and scale out network. And this discussion is discussed discussed a lot in yesterday's side meeting. We have a side meeting for this topic specification. So when we talked it, when we have had the discussion, many people think that beer may be an ideal choice for it. So I listed it here for your kind of reference. Yeah. So, and still we discussed some open questions yesterday because we know that somebody maybe think that we can use the existed topology such as PIM to solve this problem, or we can use other method to solve this problem. So we discussed it a lot in yesterday side meeting, and also we wanted to bring some discussion here to ask for some comments or suggestions. Yeah. So that's all for today.
Mike?
Thank you, Sandy. Mike McBride of Future Way. Sorry, I missed your side meeting. That would have been interesting. Is the primary issue in your mind scalability, and you see multicast being able to help with scalability?
Yes, because if we want to discuss scalability, we must focus on some special use case. And when we look up the use case, especially multicast case in LLM, we found that many multicast requirements is just inside the nodes. So it may need the TP to do the computation. And so the MOE scenario is the first explicit requirement for deploy the multicast across the leaf switch, even if spine switch. So we think that the network multicast technology may do help for them. Yeah.
I see.
Yeah.
So you're thinking about the future because multicast in the internet has the same kind of situation where unicast is largely being used for dissemination of multicast.
Yes.
They're doing just fine without multicast. And it seems like DeepSeek and other are doing just fine today with multicast. It's quite impressive. But you're thinking about the future scalability that multicast may be able to help.
Yes.
Okay.
So we bring the MOE scenarios here because we can see that only 9 experts are activated at a time. Yes, so we think it's scalable. And about some discussion yesterday, and our customer from China Mobile Cloud said that maybe in a few years later, it is still the number of experts will still remain in just inside the 100. Yeah, so we think that can achieve the goal for multicast. Yes. So if we'd like to discuss the scalable scenarios that across thousands of GPUs, we know that we must face some specific requirements, the explicit requirements raised here, and we can discuss if beer can be used or just PM can be used. Yeah.
Great, thank you.
Hi, thank you for your presentation. I think it's really interesting, and my question is actually it's really positive, but I'd like to know where is the appropriate venue to discuss this kind of technology venue? It's a working group, research group, or even academic conference. So where is, do you have some specific direction where you want to present this? Because it seems that you already not present, I'm not sure, but you already submitted a draft
Yes,
working group. So
I
where is
submitted the draft in RTWG, but I think that the MBONE may be the most suitable working group to be worked on, because I wanted to request the presentations in RTG working group. So I
you
submitted
already
the draft
did?
here.
You did? Or you will?
No, it's
Not yet.
it's run out of time, so I have no time to present this draft here. So, but in yesterday's meeting, we have good discussion here. Yeah.
So again, my question is, so if this is really academic, or maybe
no academic.
It's not academic.
It's real requirements from the actual deployment. So.
So
whatever the draft will be adopted or proceed or go on, we just want to find more people to do the discussion and find the possible solutions for it, so we can implement it with our customers, and we can see if we can achieve more active or predictable results. So we just bring it here to see if somebody else are interested in it. In yesterday's meeting, we have a lot of discussion here because many people think that it's an interesting topic here.
Sure, sure. Yeah. So again, this is a positive question. So where is where you want to mainly discuss? Where means a venue working. So this working group or beer working group or routing working group. So where is the best place for you?
And this in MBONE working group, it's our first session here in this meeting, and next beer session we will also discuss this topic, because the limit of MBONE time, right? But we have more time in beer working group, and we can discuss more in beer session, and also we still have a presentation in Rift.
Yes, so you have a
working group. Yes. Sorry,
So
you will see me many times this week. Yeah.
So you're saying that you have a number of slots this week, but you think ultimately that MBOND is the working group that you believe this document should belong in?
Yes.
Okay.
Okay. Thank
you. I have a question. This and sorry, we have to move on. So I've locked the queue. But my question is, you focus on MOE and LLMs, but this seems like a more generic technology or generic issue for AI data centers, specifically training data centers. Is there anything special about MOE and LLMs, or is this more a question of multicast in the AIDC than multicast in for enabling MOE, optimizing MOE deployments in an LLM. So why so specific, and why not just generic?
Yes, at first we know that there is many broadcast or multicast operations in LLM. It's existed, and but they never say that we will across the lift switch or span switch. So the solution may be solved just inside the node. So it may be some private multicast function here, and maybe the LM only use the unicast only to solve this problem. So they never used the actually network multicast. And when we using MOE, especially for DeepSeek V3, we know that is explicit use case for across the leaf spine switch. So we know that it's time to bring our network multicast technology here to help them to do the work. Yeah.
Max,
Yes.
quickly. 'cause we
Yes.
have to move
Hi,
on.
Max from TU Berlin. So one quick point and one question. So the point, there has been a lot of research work, as you are probably well aware, on multicast in data centers and specifically for LLM training and so on, right? But none of that work has focused on protocol level considerations. So I think it's a really good idea now to bring this to the IETF and see what you can do. So great for that. But if we move ahead with this, right, we should take a good look at all the research that's already out there, right? There's dozens and dozens of papers on how to do multicast in LLMs and what are the benefits and so on. And the second point, or the question, I guess, which is in a lot of this research, one of the big issues, and that this might already be too specific for now, but in RDMA and other protocols like RDMA, you probably also well aware is that you directly write into the memory, so you need the memory address, right? And different nodes usually don't have the same memory address, right? So there will be need for mechanisms to overcome that issue, because it's not maybe strictly multicast, because you send the same data, but you send it to different memory addresses, right? And you would have to modify RDMA and so on to keep that, just to keep that in mind. Okay.
Thank you. We also have this discussion yesterday, and we know that when we use the function between nodes, we always use RDMA, and then it's just read the memory. If we just broadcast the address to the experts, and every experts will receive their data just from the source GPU. It's still unicast, right? So when we use the multicast here, we must change the large models coding. So he may change the data transfer function for it. Yes. Thank you.
Great. Omar, sorry, we have to just, we have to move on, but so how about this? You have a couple more presentations this week. See how it goes, and then maybe bring it to the list and see, based on the feedback you've gotten all week in the various places, and see if you still believe MBONED is the right place to bring this, and we'll have discussion on the list.
Okay. In the same room, the next session is beer, and
Okay.
we will also discuss this topic. If you want to discuss more, we can discuss in that session. Yeah.
Okay.
Thank you.
Thank you. All right, Max, you want to come on up? And Max, I'm going to give you,
I hope I don't need the
okay. So Max, you're going to pick up, cover all three in one, and we'll give you 25 minutes.
Okay, perfect. Yeah. Hi, everyone. I'm Max. So this is about the dorms cluster.
Here. There. Now you have control.
Okay, perfect. Thanks. So yes, this is about the dorms cluster that Jake Holland initially started. So thanks a lot to Jake, and we miss you. They have been inactive for a number of years now. And we want to pick them up for various reasons, right? So this is Kairos and me trying to get them over the line. They have all been adopted and so on. And originally the intention was for these drafts to be part of the multicast to the browser use case, right? Where you wanted to get multicast into browser somehow, and especially for video streaming. And these were parts or like technologies that Jake at the time thought, and I agree, would be necessary to do that, right? So it's like tools in our toolkit. So yeah, there's all of the drafts on GitHub if you want to contribute. And since it's been, a couple of years since this was talked about, I will briefly reintroduce them, I guess, right? So talk about all 3 of them and then talk about what our plan is going forward, and also what the state of the documents is. So first of all, DORMs, discovery of RESTconf metadata over source-specific multicast. Good acronym. Basically, this is the anchor or the baseline for the other 2. So it's used to allow people to discover metadata about the source-specific multicast stream using reverse DNS, right? So you use the source address of the multicast sender of an SSM channel and do reverse DNS lookup that will point you to a record that has the IP address of a DOM server, and then you can use RESTconf or other protocols, right? In the document it's RESTconf, but we also make sure to say you could use netconf or whatever other thing you want to use. And then from that, you can basically fetch metadata about this multicast stream. DORMS itself does not specify any of this metadata, right? It's purely the mechanism to retrieve it. But the point is that you can extend this metadata, what you can get, right? So DORMS is just introducing the mechanism, and then the other 2 drafts, CBAC and AMBI, are introducing actually useful metadata that you can use from DORMS. All right, CBAC. So CBAC is circuit breaker assisted congestion control, which is a network circuit breaker as described in RFC 8084, or at least in the end we hope it will work like this. And it basically allows, once again, any node on the network to use DORMS to receive or retrieve metadata, in this case the estimated limit, or not the limit, the bandwidth requirement for the multicast stream, right? So if you're a router on the network and you want to know there's a multicast stream, somebody tries to join, you can use CBAC and DORMS to discover how much the sender of that multicast stream advertises this stream will approximately use in bandwidth, right? And from that, you can then decide, do you want to allow the stream? Do you want to allow the PIM join to go through, or do you not want to do it, right? So this basically helps solve the issue that a lot of operators just disable multicast except for their own things because they don't know how much traffic they're gonna get and so on. So with this, each router could say, okay, I have a limit, say, instead of not allowing any multicast, I allow up to 100 megabit or something, megabit per second, and I can basically pick and choose based on the information CBAC provides, which of these multicast streams I want to allow. And maybe I also have information about how many people are requesting this multicast stream, how much bandwidth I would save if I use this, if I know how much bandwidth it's going to use per stream, and so on. So this is basically a tool to make multicast more appealing to operators and allow them to have some form of congestion control and rate limiting and so on for multicast streams. Because again, or not again, congestion control in general in multicast, I think, is one of the big issues that we have to think about, right? So a lot of these drafts predated multicast quick, right? Or like not all, a lot of them, all of them predated multicast quick. So that's where the focus shifted then. But again, CBAC is a mechanism that would be required one way or another, right? Even if we use multicast quick, it would still be useful to have this as well. And the final one, AMBI. Now this is the question. This basically is integrated in multicast quick now, right? So AMBI is a mechanism to have integrity for multicast streams. And it's very similar to the mechanism that is used in multicast quick for integrity, right? So you basically, again, through DORMs, you can discover an AMBI server that you can make a secure unicast connection. So for example, through TLS as a multicast receiver. And then this AMBI server will send you hashes, essentially, checksums for all the packets on multicast. And then as the receiver, you can go on and check the integrity of the packets you receive through multicast against the checksums that you know are correct, because they got transferred through unicast and securely and so on. And you would know that all the packets you receive from multicast are both have not been played with, and they also don't, nothing was ingested by third parties and so on. So you can trust the multicast packets in that sense. For AMBI, we have an implementation, right? But I would say of these drafts, this is the one the least useful in practice now that we have multicast quick. But I think it's still good to get this through the IETF, simply because a lot of the feedback we will get for this, especially from the security area and so on, will tell us a lot of things about what to do with multicast quick, right? Because as I said, right now the mechanism is very similar. So if people say, okay, this is a terrible idea, whatever, from the security reviews, we will know to take these lessons to multicast quick immediately. So to get this out of the way, I think it's still useful to advance this draft eventually. Okay, that was a quick overview of the drafts. And now to the state. So DORMs, in our eyes, is mostly ready for working group last call. Jake, when he was still here, asked for working group last call even, but there was not enough responses then. But since then, we also worked on the draft even further. We had closed a bunch of outstanding issues against it on a GitHub, and we refactored it a bit, edited it a bit, and so on. So it's in even better shape now. So we think now would be a good time to once again ask for working group last call. Okay, the second, so this is basically going from the draft that's most finished to the one that's at least finished, the least finished. CBAC is kind of in the middle. There's definitely more work needed before we can go to working group last call. There's a bunch of issues open we can work on now, and a few sections that need to be written. And as Lenny already mentioned, there have been 2 recent reviews, right, from Brian and Tina. So thanks to Brian Trummer and Tina. And basically they said, okay, this needs more fleshing out, right? This is still an early version, a lot of TBDs. And it also said that we need to make the mapping to 8084 more clear, which I fully agree with. And that some of the work that's going on at SCORE now, we should also look at that and take lessons from that, and notice that the time scale is important for some of the functions of CBAC. So when do you actually trigger the circuit breaker and so on, it will be important to think about. Yes, Corey. No, you can go now, it's fine.
So, Gary Fairhurst, first of all, as a secret multicast enthusiast, I'm really glad that you're bringing up the CBAC thing, because we need ways to make multicast and unicast networks attractive, and making unicast attractive isn't very hard, but making multicast this is a problem that needs to be solved. This draft is on CBAC is put forward as PS, standards track, which is really nice. Mm-hmm. Yeah. It doesn't have any teeth. It's got lots of shoulds and furry bits in there. I think we need to look at the recent output of CCWG on testing scenarios, and I really would encourage you to go to CCWG, not just liaise with them, but actually pitch up with presentations on how you do the fairness criteria. This is probably not as big a deal as it sounds, because you're actually reacting on a fairly long time scale compared to them. But if we can demonstrate these things in CCWG, I think we'll get something out which is really helpful. So I'm just encouraging that sort of thing. We tend to hate in the IETF, but please try and work between two working groups. One to talk about how you do the circuit breaker envelope, and the other one to understand all the multicast stuff, which I think are probably orthogonal if you do your evaluation scenario correct. Am I making sense, or do you think this is a difficult approach? I'm asking whether this is a good approach.
No, I fully agree. I fully agree that this should go to CCWG at some point. I didn't go at this IETF because I think the draft is still a bit rough and I want to be in better shape before I go there. But the plan is to fix it up and solve the open issues and so on, and then maybe go to CCWG in Montreal and get some feedback from there as well and what they think.
Excellent. And I encourage some of those should be musts.
Okay.
I mean, I don't know which, but
okay.
Yeah. So lovely to see this back again. Thank you ever so much for bringing this up.
Yes, thank you. Okay, so yes, that's CBAC. And then finally, MB, so the state of MB is that there's a lot of open issues. On the one hand, this is good. On the other hand, it's also obviously not good, but we at least have an implementation here. So we actually have some real world experiences, and we actually can now test properly what needs to be done and so on. So I think after CBAC is done, right, the goal is to also get AMBI in a state for maybe the IETF after that, so 125 or 126, and then have it in a state there that we can actually talk about more open or in a better way, and then also see what else needs to be done before we can move ahead with it. But also, crucially, we think that before we can get AMBI really further, we also need to talk about multicast security in general more, right? And Kai will present on this after me. So the internet threat model and so on, all of that is there, but there's no real threat model for multicast traffic. And if we want to tell people on what is MB actually solving, we might have to make sure that this threat model exists first. So we see about that. But yeah, that's basically it, right? So what are the next steps, or what we plan for the next steps is that we should ask for, or we want to ask for working group last call for dorms now. And then for CBAC presented at CCWG and in Montreal, and depending on how that goes, ask for working group last call sometime after that. And then with AMBI, we basically have to see what happens with the multicast security draft, and also how we get along with the rest of the draft. All right, thanks. Questions, comments?
Great. So yeah, I think we can go to working group last call on dorms, given the history on that one. So we'll take that one to the list.
Great.
Great. Thank you. You're still up.
Oh, yeah. Sure. All right. Yes, so this is a presentation about a research paper we did. And I think I presented something similar before briefly, but the idea is, and this came from Mankamano, who is not here today, but the idea is that we often in multicast, we know about as we use it in CBAC, we often know about the bandwidth requirements of senders, right? So CCTV cameras, they have a certain bit rate, and we know that in advance, and it usually throughout the multicast stream, it doesn't change and so on, right? The same with sensors and a lot of other things. But all of our current routing mechanisms, protocols, PIM, whatever, BIA, they don't take these bandwidth demands into consideration, right? Which leaves some space for optimization. And in general, in research, a big thing now is this work on demand aware networking, right? Where you know the demands and you can make better routing decisions and so on based on that. But because we don't take these into consideration, we often end up with congestion and suboptimal resource usage and so on. And the focus of this work was to optimize the link weights, so you can do routing based on link weights, based on these bandwidth demands. And we did a bunch of theoretical stuff, which is probably not at all interesting to MBOND, but we came up with 2 heuristics. Okay, so first of all, this assignment is NP hard, right? So you need heuristics. There's no good algorithms for it. Even with a very simple model where you only have 2 link weights and a single receiver, so basically unicast and planar graph. So in a very simple case, you already are NP hard, so you need heuristics. And then we have come up with these 2 heuristics. Again, not going to waste too much time going into them. The paper is linked at the end if you care about it. But the point is that on a bunch of technologies, you end up with good running time, right? Good performance. So the DA picky is more or less in the same magnitude on running time as the oblivious approach. So this is the running time of building the multicast trees. But while it's on the same running time, you actually get quite a lot of performance improvements on a lot of different topologies, right? So up to 10% or something reduce of the maximum congested link in the network. So, but why am I presenting this at MBOND? Well, the question is, from an operator's point of view, is there any interest in this kind of work, right? Is that something you consider for your networks, that if we would take the bandwidth of our senders into consideration, is it something people care about? Is that something we should work on? Should we think about extending existing protocols to take this into account instead of being purely theoretical? And yeah, that's basically the question and what I wanted to present.
I'll kick things off. This bandwidth reservations, or let's, I guess more generically, traffic engineering, and more specifically, bandwidth reservations is something that's part of point-to-multipoint RSVP. Are you familiar with some of that work? And that's been used somewhat extensively by video distribution providers. Is that something that you have looked at? Do you feel like there are things missing in that architecture now? Yeah.
I have not looked at it. What is it called? Point-to-multipoint RSVP?
Yes,
Okay.
point-to-multipoint RSVP, and what routing was, I guess, Jeffrey, you're a little more familiar with that. Was that ever specified? Was that just using the base RSVP spec? And what working group would that be in? Would that be T's?
Yeah, the only multicast protocol that can do bandwidth reservation today is RSVP P2MP, I believe. And I don't know if it would belong to MPLS or TS, probably TS working group now if we need to do any work, similar work there. But I guess if bandwidth reservation is important, probably the simple answer is just use RSVP P2MP, because other methods you would have to enhance the protocol and then get new implementation and things like that.
Yeah, and that spec has been out a long time, maybe like
Right.
2007, 8
Yeah,
time
it's been
frame.
there for a long time. Yeah.
Okay, I looked at
Something like
PIM
that.
and so on. Yeah, okay. Right, thanks.
Any other questions? All right. Thanks for sharing this, Max. Okay, next up is Kyle. Let me bring your slides up, Kyle.
Yeah, you can transfer, pass control of them to me. So it is 4:30 a.m. where I am, so I apologize to everyone if I'm not 100% coherent. So I'll try and do my best. All right, so the problem we're trying to solve for is how do we conceptually fit multicast within the web security model, like meeting the spirit of what the web security model is trying to achieve. So these are the four main elements of the web security model: confidentiality, like protecting the content from unauthorized users; authenticity and integrity, making sure that the content comes from the trusted source and has not been tampered with; and non-linkability, making sure that a passive observer can't track a user across the web as they transfer between networks and whatnot. So for unicast, TLS provides three of these, with some aid from certificate authorities infrastructure. And non-linkability is partly mitigated by a variety of measures. It's not, there's no perfect solution there. And I always, just editorializing a bit, a lot of the attempts to bolt perfect privacy onto the public internet seem a little bit futile to me, but that notwithstanding, there are the point is the spirit of this is to make it as hard as possible for passive observers to be able to do find out what a user is watching, for instance. So what about multicast? Like, how is it different? Well, authenticity and integrity are pretty much the same. They can be provided essentially cryptographically. But confidentiality and non-linkability they require a different model, a different way of thinking about the problem, right? So for confidentiality, multicast is explicitly for shared content, right? So many people are going to have access to keying material. So you have to think of confidentiality in that case as being limited to a group as opposed to being a private pairwise communication. And then non-linkability, again, multicast is for shared content. So it's the problem's a little bit trickier, trying to prevent, trying to preserve the privacy that the web security model is really aiming for. We have to think about it a little different way. So for confidentiality, unicast, it's obvious: unique transport keys per endpoint pair. You could still do traffic analysis, so you get access control and some privacy up to the limits of traffic analysis. And with multicast, you can protect it from unauthorized users, so you only hand the keys to authorized, say, viewers of a video stream. But those encryption keys are shared by all authorized users. And it's still vulnerable to traffic analysis and clear text metadata. So you really only get access control. You don't get privacy from the confidentiality. So how are we going to get privacy from, within the multicast ecosystem? And what does privacy actually mean? So some work that Dave Plonka and a few folks did several years ago, that actually goes back even further. I have some references in the draft for the original appearance of this, but this is how I got pulled into doing a lot of this work, is this notion of k-anonymity, right? So k-anonymity means, let's say you have a tap point somewhere on the internet, and you know that someone is, like the person that you're trying to target, let's say you're trying to track them, is behind this tap point on the internet. When there are many such users that share the same identity, let's say there are K users that share the same identity, that means that user is K anonymous. It could be any one of those K users behind that tap point. So what does that mean? Well, so with multicast is hop by hop. There's no end-to-end addressing. So in order to be able to know what a user is doing, you need a tap point close to the user. So, to know who is subscribed to what, for instance, you can't be in the core of the internet observing a unicast stream from 30 hops away. You need to have a tap point that is fairly close to the user's access network. Then there's also no standard mechanism to discover content given the source and group. So what you could do now, since as Max was saying before, we developed dorms specifically to be able to map a source and group to metadata. What you could do to avoid so you want to be able to give, part of the reason for dorms is to give the network the ability to learn something about a stream so it can do adequate load balancing and pruning of streams in case circuit breaker activation is required. But what you could do is limit the metadata that unauthorized, say, public users have access to through dorms, and provide richer metadata to authorized users. Right, so dorms can be access controlled to minimize the metadata that is offered to, say, the feds, right? So, and also there's typically going to be some kind of unicast control plane. You need to learn about the multicast stream somehow, and that is protected by unicast confidentiality. So we get some of the benefits of unicast at the stream setup phase. And if you do it right, linking the unicast control plane to multicast delivery is limited to traffic analysis, which is that's at this point the best that we can do. So, there are other things. This one's kind of a throwaway slide. I mean, it seems kind of obvious to me, but I thought I'd point it out. Right, with multicast, you have this problem that, well, you don't want to send personal data to many users on the same multicast stream, right? You want to send, if there's personal data, you want to send that in unicast. But I mean, this is no different conceptually than asking providers not to post social security numbers on public internet pages, et cetera, right? It's just, this is sort of common sense, so I'm not going to spend a lot of time thinking about this, but it was something that was worth mentioning. The mishandling of personal data happens at layer 8, not at layer 2. So there are a bunch of other issues that we discuss in the draft: forward secrecy, request response binding for cryptographic binding of requests and responses, which is another sort of maybe a little bit arcane requirement of the web security model, but it's worth addressing. Linkability across network changes, and a few other things. Now, I put this last because I think it's important to emphasize this point. Something multicast shaped is happening. It's unavoidable because live video delivery does not scale to unicast. Right, unicast, it's just, if you replaced every person who is currently has a cable subscription with a unicast stream, the internet would fall over. And Jake demonstrated this with some graphs a few years back. Right, so the real question that we want to ask ourselves when considering whether this work is worth doing is, do we want that multicast shaped solution to be an open technology platform that is based on open technologies that anyone can deploy, or do we want it to be something that is proprietary, owned by CDNs, and has perhaps additional attack surface and tap points that we don't even know about and can't observe, right? So I mean, I come down on the first side of that. I would prefer that we make use of the technology that's already been devised and augment it to provide the properties that we want out of security and privacy for multicast for the web, rather than essentially replicating all of that infrastructure with something much more heavyweight and proprietary. So with that, are there any questions? I hope that made sense.
Kyle, can you talk about, was this draft presented in elsewhere prior?
Yeah.
And
So an
are
earlier
you,
version of this
are you,
draft,
is the goal to seek adoption here in MBOND?
yeah, I should have mentioned that. Yeah, so I am seeking adoption here. I'll give you a brief history. So this, I think we probably presented it, I want to say to Sec Dispatch maybe back in 2019, something like that, an earlier version of the draft. Because at the time we were saying, well, maybe we can, like spin up MSEC again. That didn't go especially well, but I think we didn't have a really good story at that point, and it was, so the draft was kind of a like, who ordered that sort of thing. Like, what are you trying to do? Maybe define the problem space a little bit better before coming to us. I think it's probably reasonable for MBOND to adopt this work, even though there's, even though MOD's wheelhouse is really multicast technology as opposed to security and privacy considerations, but with some special attention paid to it from the security area as we move it through the process. So that's the long version of the answer. Yes, I would like to seek adoption here.
Great. Omar?
Yep. Hey, Kyle, thank you so much. And to you and to Max for picking up the work here on multicast for the web. It's been a long time in the works, and the demand for multicast is now more clear than ever. We've been strong proponents of this technology, and we're multicast deployments, this working group, and thinking about how do we get this technology out to content providers and applications, and the reality is that it's not going to get to the browsers as the first step. So I've been thinking a lot about how we can use these kinds of protocols within CDNs, right? And thinking about multicast as the transport, and that interfacing with existing unmodified applications, similar to how mod or MABR, we have also a very similar kind of protocol. And there's incremental deployments where you can put these within CDN nodes, within core networks, for instance. And with the commercial availability of home servers, projects like Purple Foundation, where we're able to put these inside modems, and there's folks like Broadpeak who are also doing this as well. But thinking about how this can eventually make it to the browser, and looking at the security model from an incremental perspective of what it would take to adopt and roll out this kind of infrastructure on a more practical timeline. It does, I would love to see standardization. We have mod, we have MABR that are focused on live. One of the big things that Jake had initially brought up as well was using this for, say, video game downloads or software updates. And having standardization around how this would work for different modes of traffic that are non-live, and there are some gaps, and a lot of the work that's being done on that front is proprietary. So I'm really happy to see you guys here today. And I would love to engage with you, particularly on the security model stuff. There's a lot of open questions there. And yeah, trying to figure out what's the best forum and how we can keep this work moving forward. Would love to, endorse these drafts, and be able to continue to work on them with you guys.
Great. Yeah, no, that's awesome. I'm glad to hear that there's some enthusiasm for this. Lenny, do you know? Can you maybe ask how many people have read the draft?
Sure. Yeah, a quick. Oh, actually, I had a show of hands for.
It's not
prepared.
super long, so folks who haven't read it, it's.
I have a while ago.
Yeah, I
I
mean,
don't know.
well, it's been dormant for 3 years or something. So yeah. But yeah, the mod work while we're waiting is I just learned about that a couple of weeks ago, and it sounds really interesting, and it's in the same basic space. So
Yeah, their goal is to make it live video, make
sorry, Omar, I lost you if you're talking.
Yeah.
Could I do a quick clarification on the poll? Because this has been around for a long time. I remember reading this ages ago. But is
Okay.
that what you want, or do you want to?
Yes.
Yeah, so any version of the draft.
Kyle, that was your question. Is this dramatically different than previous versions?
No, it's not dramatically different.
All right.
intermittent connectivity here.
Folks,
Sorry.
please, if you have read this draft, please add to there is a poll ongoing, just to give a sense.
Yeah, I mean that's pretty good actually. Okay. So just about half.
All right, we'll terminate that. Omar, are you still there?
Yeah, I'm having intermittent connectivity, but I was commenting on mod and how that's an example of transparent multicast focused on live delivery, where that can be deployed on, say, a BHR and working with unmodified applications. So it's awesome to see more implementations. Mod doesn't work with non-real-time files, say, the software update or game downloads use case. So we have a solution very similar to mod. We're a small company, and just the amount of cycles that we have to be able to put out a draft is very limited. Would love to.
What is your company?
We're Blockcast. So we're a CDN and have native multicast capabilities within our edge caches for non-real-time and real-time media. So essentially allowing for unmodified applications that would expect an HTTP interface to leverage multicasts, and that can be deployed within a core network or within users' homes, eventually to mobile phones and so forth, but making it essentially easier for app developers that expect and only know HTTP to leverage multicasts, and transferring the burden of understanding the mad science behind multicast to the CDNs, at least initially.
Right. Okay. Great.
Yeah,
let's talk. Out of band at some point.
Yeah.
Neither of us is in Madrid, but
yeah. Yeah, I would love to touch base with you and Max. I've touched base with Jake a while ago, so it'll be good to find us a time.
All right, cool.
Hi, maybe it's a stupid question or a very, very basic question. So does your proposal use IGMP or MLD, just web-based multicast communication?
I mean, it's not specific to a particular technology. I mean, it's not this draft is not a specification. It's essentially a security and privacy analysis.
Mm-hmm.
So the actual the technologies in the presentations that Max made, I'm not prepared at the moment to talk about what's in them, mostly because my brain's not working especially well. So.
Okay, because without any protocol extension, I'm wondering that how we can enable the secure communication, secure multicast communication. So that is the reason why I'm asking.
Well, I mean, group membership protocols are a local network phenomenon. So it's not our focus hasn't been there. We've just basically been assuming that stuff it kind of exists and is the foundation, and we'll just build multicast on any multicast security protocols on top of that, expecting that the local network has its shit together. So
Okay, so what is the main aim to, well, actually, this is really similar question to me yesterday. So what is the real goal or the main aim to provide this document as an RFC?
well, the aim here is to define what it means for multicast traffic to meet the web security model in spirit, right? Because the web security model is specific to unicast, and it has some normative requirements that are not achievable by multicast, but there is something conceptually similar in in some of those cases that meets the spirit of what they were trying to achieve by with the specification of web security model. Does that make sense?
Okay, so this, well, maybe your goal is to initiate or to promote the SAM protocol extension to keep or to maintain the multicast, secure multicast communication by extending some protocol, right?
Well, ultimately the purpose of this work is to make it so that we can convince the people who are essentially the gatekeepers for getting technology into the browser to accept patches essentially that will enable web traffic to receive data enable web browsers to receive data from multicast streams as part of the as part of kind of standard web traffic.
Okay.
Right. And so this is a document it's kind of an argument in favor of allowing web traffic to incorporate multicast receives. Does that make sense?
Okay, okay, thank you.
Okay.
All right, one last really quick question, Human, because we have to move on.
Yeah, sorry, I did read this draft, and I think it kind of I got my question answered, but just to make sure, the security portion of this is from the source to the browser. I mean, if it's from the source to the browser, and you're trying to do multicast replication on the source to all the browsers, it makes complete sense to use TLS. But what kind of throwed me off is that at some portion of this presentation, it was saying that it's hop by hop security too. And if you're trying to use hop by hop, as you know, there's a ton of technology out there like MACsec, IPsec tunnel mode, that are maybe a little bit more suitable to do hop by hop multicast
Yeah,
security rather than TLS.
I think I must not have been explaining it very well on the deck, because it's not hop by hop security or hop by hop confidentiality. The hop by hop reference was to an analysis of the privacy implications of with multicast. If you are receiving a stream, you're subscribed to a group, to a source in a group, and you're receiving a video, and someone else is also subscribed to the same source and group, you're watching the same thing, right? Which violates the normative letter of the law in the web security model, that a passive observer can't know what somebody else is doing up to the limits of traffic analysis. What that slide, going back to here, was trying to get at was that you it's that problem of knowing that someone else is consuming that stream. That's where the privacy is reintroduced, because unless you have a tap point that is close to that user, how are you supposed to know that they're looking at that stream? It could be anybody on that network that is looking at that stream. If that data if one person anywhere inside that network is subscribed to that source and group, you're going to see one copy of that data flow into that network. So if you only have a tap point outside that network, it could be anybody inside that network that is consuming it. You don't know who.
So Kyle, we have to move on, but maybe we could take this to the list.
Yeah. Okay.
So just Luis, if you want to start to come up, while Luis comes up, maybe we could have a quick show of hands. I think this probably might need some coordination with the security area in order for us to adopt and make sure they're okay with it. But just a quick show of hands just to get a sense of the room. Is there interest? This is non-binding. Is there interest in taking on this work, adopting in MBONED? There's a quick poll going on, so please give us a sense of whether there is or isn't interest in this. Cool. So it looks like right now it's at 13-2, 13 in favor, 2 not in favor, and 3 not in favor, and 2 with no opinion. So it looks like there is a decent amount of interest. Maybe we could take this to the list. We should also probably take this to the security area as well. So thank you, Kyle, and thanks. All right. Fortunately, we're very tight on time. Okay. Though this is very important work, so.
Thank you. So it's just an update to what I presented in Dublin. So the idea of this work is quite similar to what Jake did with multicast quick. Here was just a different approach, and it's related to the implementation. So the idea is to modify the quick transport protocol to be able to do multicast inside it. So for this, we would have we would initiate a connection between a receiver and the source, and then when the connection is open, so it's the orange pass. It's a per receiver secure connection used for control information, and for example, if you have to fall back on unicast, and then we have this blue pass which is shared between multiple receivers, which has an IP multicast destination address that will help to send data more efficiently to the network. So this idea entirely relies on multipass quick, which is being standardized in the quick working group. So it easier a lot of things, especially regarding the receiving side, because basically, except from some control frames, for example, to announce the channel, etc., we don't have a lot of modifications on the receiving side. So it's quite interesting in that perspective. So since the last time I presented this in Dublin, now we have a released implementation. So it works. And I'm working on a new version with the new updates from Multipass Quick. But basically, the implementation works, so you can already play with it if you want. Yeah, so it's based on Cloudflare Quiche. So it doesn't work per se on the browser, but it's an open source implementation. Just to give a small results with this implementation, we could reach on the limited testbed, we could reach more than 80 gigabits per second of communicated traffic with more than 1,000 receivers. So I'm not sure exactly what are the use case, the range of receivers in the use case we have here, but basically with the result I got, the fact that we had 1,000 receivers, so 1,000 of backup pass connections was not a problem for the server. So that's just a first idea of scalability that we could reach with the limitations we had. Now, the next step for me at least is to try to gather people into testing this implementation and to play with it on the internet. So that's just a complex image that is quite easy normally for you to understand because of AMT. But the idea is that I will, yes, so I designed a small push-based RSS application to let people play with this. I hope to now work on a video streaming application because it takes much more time to implement, but the idea is to do the same, but with a video streaming application. And so for this application, I already provide Docker images. So you can just download the Docker image, run it, and you will connect to our source inside my university network. And you will connect to the AMT relay of our university network, and then you will receive the content using FlexiCast Quick. And for those of you who know SIGCOMM, which is a networking conference, I will do a demo there in September in Portugal. So if you are interested, don't hesitate to talk to me after the presentation. And also, as a small note, I would like also to test on wireless networks like Wi-Fi, if you're also interested to do experiment on this. So that's it. This QR code is not for the implementation. It's for a scientific paper that we published about this implementation and the design. I think now the next step would be to try to integrate to 3DN. And of course, I know that there is Jake Holland's draft on Multicast Quick that Max is also working on right now. I already spoke with Max 2 days ago. And I think the next step now is to try to merge the two drafts, at least to find something common and maybe do some interrupt tests at some point. So the idea for the next IETF would be to merge the two drafts, or at least to only present one thing. But yeah, so that's it. Thank you.
Great. Any questions?
Hi.
We have time. If you could be really quick, though.
Sure. Yeah. François Michel, Apple. Thank you for the presentation. As I said last time, it's really great. My question is, what is the IETF next step? Are you trying to get an adoption somewhere? I saw that the draft is in Quick, but there's also an opportunity maybe in MBONED. I don't know. What's your opinion on that?
So regarding the protocol, because it's an extension of Quick, I would say that it may have to stay in the Quick working group. Last time I spoke with Lucas, who is the chair of Quick working group. He told me that to hope to advance in the working group, we have to have an implementation. So now that we have at least one and maybe two soon, I hope that maybe it will help to move forward. I think we won't go much further as long as Multipass Quick is not published as an RFC, because this work relies on the Multipass Quick, and because the Quick working group has full time on it right now. For the MBONED, I have no idea what would be the greatest thing to do, because it's related to Quick, or maybe we could write some draft with the specifications that I don't know. So if you have any opinion, that would be nice.
Okay, thank you. So if you need support for the draft for Quick or even here, let me know. And I would be happy to know if anyone else is interested to making this move forward. Thank you.
Thank you.
Great. Yeah, thanks. So let's take is it super fast?
Jeffrey from HP. Curious, how many receivers can you handle on the source?
So on our test bed, which was quite limited, we reached 1,000 receivers. But when we look at the results, it seems that we can do much more. Like the image on the bottom shows that the CPU usage was more or less 50%. So I think we can have much more receivers. But on our test bed, because we were limited by this, we could not reach much more than that. But I hope to gather more receivers than that.
Thanks. So we'd love to hear more discussion on the list, also in Quick, and that would be great if there could be personal opinion merging this with the existing work. I think this is really, really important stuff.
Thank you.
Great, thank you. So Prasad, sorry we're not giving you very much time at all, but this is a deployment draft in Lisp, and we wanted to give Prasad an opportunity to share and make MBONED aware of this work.
So next slide, please.
So you have roughly 1 minute. Sorry, Prasad.
No, that's okay. I mean, I don't think I'll be going into the details, the lack of time. But please read the document and send comments. On the mailing list, we'll definitely be very happy. What we do cover is a wide range of deployment that has happened across many industry verticals. Uh, Based on the PIM or PIM solution that we proposed in the draft. Yeah. That's it from my side.
Well, you did that in less than a minute, so thank you, Prasad. So one of our chartered items is to review documents in other working groups, and I think this is a something that we can provide value in review. Just one quick question, out of curiosity, Prasad, why Lisp and not MBONED for adoption?
That's a good question. So this work is essentially done to progress 6831, which is an experimental RFC to standards track. So one of the comments that came up during the review of 6831 was, if you are making an experimental draft to standards track, then please provide a section for deployment experience. And then we thought that there is more than enough material to just cover it in one section. So we thought a standalone document would really do justice to the topic, and that's why we have a separate informational draft.
Okay, thank you. Thank you, Prasad. We look forward to Montreal, and we'll reserve more time for Montreal. And Prasad, maybe maybe it'd be good. We'll save you a little extra time in Montreal if you want to go a little deeper into this, so you can get more review. But in the meantime, please do take it to the list.
Sure. Thank you, Lou. Thank you.
Thanks. All right. Anything else from anyone else? Otherwise, thanks for coming, and we'll see you in Montreal.
Thanks, everyone.
Thanks. Yeah. Yeah, this is good. Sure, yeah, and thank you for your help. Welcome aboard. What's that? Hope you can hope you're here in Montreal. We're very close to some hot mics, so yeah. Let's go back here because beer is in here